Hi everybody, let's get started please. I've got some reminders and announcements before we begin. First up, please remember that we're not having class on Thursday. I'm not going to be here. I'm leaving tomorrow. So there's no class on Thursday. If I were you, I would take the time that you had reserved for class on Thursday and maybe spend that starting on homework 3. Starting on that homework assignment, because it is going to take you some time to get that assignment finished. So, use that time wisely. Get a jump start on homework 3 before you get bogged down with midterms and other stuff. Speaking of midterms, the exam is next week. Next Thursday is going to be our first exam. I will post some past exams probably by Thursday. Actually, I'll try and get those posted by Thursday, so you can take a look at them, and then we can talk about them on Tuesday of next week when we have a review session for the exam. Let's see. There was some other stuff I need to talk about. Oh, yeah. I just mentioned I'm leaving tomorrow. That means I actually will not be able to have my office hours tomorrow either. So my office hours for tomorrow unfortunately have to be canceled. My flight leaves at noon, so I won't be able to come into work and have office hours. I will still be available via email and via Piazza, and we have lots and lots and lots and lots of other office hours available. So I'm sorry that I won't be able to be there this week, but please don't hesitate to reach out to me if you need something from me while I'm gone. And also, in terms of the assignment, the unit tests for homework 3, I went through them yesterday. I was actually very, very happy with how they turned out. So thank you very much for taking some time, putting some effort into those. I think they all turned out well for the most part. And so I gave you back some unit tests that you can use on the homework assignment. I am like 99% sure that the tests are okay, but if you find a bug or two, that wouldn't surprise me either. Just let me know so that I can get that fixed as soon as possible. And let's see, what else? There's one other thing that I unfortunately need to talk about. It's bad news. I discovered that there's been some academic dishonesty on some of the assignments in this class. So before you start freaking out, let me just go ahead and say that the cases that I saw, there were 2 cases. They were very blatant, straight copy pasting of stuff that was not their own work. I'm not submitting things that are super borderline, right? The vast majority of you have done nothing wrong, and you're all good to go. I'm not worried about you, but for a very small group of people, there were 2 or 3 students that submitted copied work on the first homework assignment. I haven't actually checked the second homework assignment yet, but I will. I did find some people on the first homework assignment that are going to be submitted to the dean's office, and I'm going to recommend that they fail the course. That's what it says in the policy. I'm going to recommend an F in the class. So I just want to make everybody aware that I am checking. I told you this at the beginning of the semester. I take it very seriously. I am checking. I have found some people, and I will continue to check. And I really hope that I don't find any more. It's not fun for me or for the students involved, but I thought it would be fair just to notify you that these things are happening. All right, that was a lot of stuff. Are there any questions about homework assignments or the schedule or the upcoming exam or anything like that before we hop into today's material? Any questions at all before we get started? Okay. Fantastic. So today is the last set of new material that we're going to have before the exam next week. What we talk about today is fair game for the exam. However, you'll see this when I post the past exams. I actually tend not to ask a whole lot of questions about today's material. It's a very practical set of material that we're going to be talking about today. We're going to be talking about the front end, which is basically, I have a database. All right, how do I connect that up to an app that I want to use the database? And there's lots of different ways that we can do that. I'm going to show you a few different ways that we can do that, run you through some examples in class today. And then I posted some code today as well, so you can take a look at this code And if you have a database app that you want to make, you can use it. If you want to, you have my permission. You're more than welcome to take this code and modify it to suit your purposes. So I'm going to show you a few different ways of connecting your database to a front-end application, which is very important, right? We know SQL, or we're familiar with working with SQL. We're programmers. That's what we do. But the vast majority of people who use our apps are not going to know about SQL. They're not going to care about SQL. They sure as heck aren't going to want to write SQL queries. So we need to provide ways for them to interact with our database that does not require them to write code, basically, is what we're getting at in this class. And so there's a few steps that we need to take to get those things set up properly for our users. So, do your users want to use the database? Do they want to write SQL queries? The answer is no, definitely not. For the most part, the answer is definitely not. And even if they do know SQL and could write a SQL query, like we know SQL, right? How would you feel if you went to Facebook and it said, all right, write the SQL query that looks up your password and make sure that it matches? That would be really weird and kind of awful. Nobody wants to do that. It's inconvenient. It's inconvenient. So it's our job as programmers to make sure that we have these things hooked up to make the access to the database easier for our users. And so we're going to see actually 3 ways of accessing a database. One via a website. We're going to use PHP for that. One via an application, which we're going to use Java. So I'll show you how to hook it up from Java. And then I'm actually going to show you a second way of hooking it up through Java at the end of class. So the basic setup. This is true regardless of what language you're using, whether it's a website or a Java application or some other language that you're using. The basic setup is the same for all database access, which is the good news. You got to install some drivers. So a driver is really just a small piece of code that says, how can my computer, right? How can my application communicate with the database? That's all really a driver is. It helps you make a connection to the database. So once I've installed the driver, then I can actually create the physical connection between my application and the database that has my data that I want to work with. I can prepare and then execute my query. You might be wondering, why is that a 2-step process? Well, I'll show you in a little bit why we break that into chunks. And then once the query is executed, I'll process the results somehow. That's the general idea. So I'm going to show you some PHP examples first. How many of you have worked with PHP? Anybody? Oh, wow. That's way more than what I'm used to. So that's good, actually. That'll make this conversation a little bit easier to have. Most semesters, there's like 2 or 3 people, and so it takes a little bit of work to get everybody up to speed. But this should be great. If you haven't worked with PHP, please don't hesitate to ask questions if something's unclear. I actually think these examples are short enough and simple enough. There's not going to be anything too crazy in there. What I have done, for those of you who have been following along with the studios, I'm not sure how many of you have been doing that, but for those of you who have been following along with the studios, the very first studio asks you to install this program called MAMP, and then has you load up an example database that has employee data in it. And so I've already got that set up on my machine. It's already on here. I can show you. Again, if you've done the studios, this is all familiar to you, presumably. But if you haven't, we can take a second just to kind of show you where we're at. I can load up this tool called PHP-MyAdmin, which is going to take us to the administrative portal for the database that's installed on my computer. It's taking a long time. I'm not sure why. Usually it just loads right up. Okay, here we go. And so the one that I'm interested in, I've got a lot of databases actually over here. These are all different databases. The one that I'm interested in is this employees database for right now. And I can expand and see how many tables I have, right? And I can see, all right, there's an employees table. And I can even actually click through here. And here's a little sample of what this employees table looks like. This isn't the entire contents of the table, I don't think. It's just the first, 25 rows or so. But it gives you an idea of the structure of this table, what kind of data this table contains, and I can actually do this for the other tables in this database if I want to. And so my question is, okay, I've got this employees table. How can I pull stuff out of it? How can I actually grab information out of this table and use it on a web application? That's what I want to do today. So let me show you the first web app that I've got. It's a very simple one, very straightforward one. I made a PHP file. Where is it? So if you've installed MAMP, one of the things that it does is it also installs a web server for you called Apache, the most common web server that's used today. And so you can host a website on your computer if you want to in the MAMP folder within a folder called htdocs, hypertext documents, website stuff. So if I go in here, I got a few PHP files, and I'm going to take a look at this display table one first. I'll open it up in a text editor so we can take a peek. Now, right off the bat, this is all HTML. That's, very straightforward. And then I hop into some PHP code. Right off the bat, I do something really dumb. And you can see that this is really a bad idea to hard code my username and password in here. That's not a good idea. That's not secure at all. Also, the username and password are just the default username and password for the database. That's also a really bad idea. But today's not about security. We're going to talk about security later on in the semester. Today we're just going to talk about how to get database access through a website. And so in PHP, right, the first thing I need to do is create a connection. So this is what's called a connection string. This is what's called a connection string. This is the type of database that I'm connecting to, MySQL. This is where the database lives. So localhost means it's on my computer. If it's not on your computer, then you would put an IP address here or a web address here, right? Some server name here. But it's on my computer. This is the database name that I want to access. The database is called employees. And then the port number is something that you configure when you install the database. So you can find that in your MAMP settings. If you go into the preferences and look at the ports tab, you can see that the port is listed here as, well, I know that text is too small to read, but you'll have to take my word for it that it's 8889. That's the port that we're expected to communicate on. So that's what's called a connection string. It gives all the information necessary to create a connection to my database. And the next thing that we're going to do is create this PDO object. It's a PHP database object. It takes the connection string, the username, and the password, and then creates a connection to the database that I have requested. So that's the first step, create a connection to the database. And now I can prepare and execute my query. This is straight SQL here. There's nothing special about it. Select two column names from table name. It's not even that complicated of a query. It's just a straight SQL statement. And so I'm passing this to my PDO object and saying, I want you to execute this query. Once it does, it's going to give me back a list of results. It's a list of tuples, basically. And so I can write a loop to go through, fetch each row one at a time. And then you can see I'm treating it like a dictionary or a hash map. I plug in the name of the column that I want, and it gives me the value for that column, which I can just print out to the page. Okay? This is about as simple as it gets. It can get a lot more complicated than this, but this is about as simple as it gets for database access in PHP, and I can show you that it works. If I go back to my browser and type in localhost, the name of the page was, what was the name of the page? It was simple, hang on, let me make sure I get this right. Display table, I was way off. Display table.php. All right, there we go. It ran that query, and you can see, actually, I still have the values up, right? First name, employee number, Georgie. Where did they get these names from? I don't know. There are some good names on this list. I kind of like them, actually. Right? Here it is. It's an entire dump of the table. you can see there's actually quite a lot of rows, which is worth talking about, right? So clearly this did what I asked it to do, and I have no problems with it. It did exactly what I told it to do. Give me all the employees from the employee table, their first name and their employee number. But in practice, that's probably not what we want in our applications. We're usually looking for one person or maybe a small group of people. And that's important. Remember that when I do stuff like this, when I have these queries, that's sending a request out into the internet to your database server that's going to execute the query, package up the results, and then send those results back over the internet. We're lucky in this situation because the server is on my computer. But in the real world, that's not going to be true. The server is going to be somewhere else. And so if I have it package up thousands of results and send that request over the internet, it's going to take time for those results to get back to me. And the more data that I request, the longer it's going to take. The longer it's going to take for those results to get to me. So while this example works, and it's a perfectly valid PHP example, it's also a good example of kind of a bad query to run. We want to be a bit more selective with our queries. We want to narrow that data set down so that we're not waiting a lot on data transfer to get our information back. I don't know if this has happened to you. It certainly happened to me, where I go to use an app, whether it's online or on my phone or whatever. I fill out a form or whatever. I hit the button, and then what happens? It takes 10 minutes. Well, that's an exaggeration, but you know what I'm getting at, right? It takes a long time for that data or whatever's that action's being performed to happen. And that's because, at least in part, due to some database access taking up some time. So let's see a second PHP example that allows us to be a little bit more selective. Let's grab a name from a form, have the user type in a name, and then search for whatever they ask for. Let's try that. I have a second example. Let me go to nameform.php. And it's just a very simple form. I can type in a name. I know Parto Bamford, let me zoom in on that, is one of the people on my list. I just looked at it and pulled, whoa, hey, don't do that. I just looked at it and pulled out one that I saw, Parto Bamford. So I plugged in his name, and if I hit submit, it pulls back his employee ID number. This is a much better example of how we might use this in practice, right? Grab some information from a user, use that to tailor our query to pull a particular value of interest instead of just pulling the entire table. So let's take a look at the code and see how this works. We've got two files now. One for the form, that's what's got the text boxes on it, and then another to process the form after I've submitted it. So if we take a look at the form first, this is probably the easier one of the two to take a look at. It makes a couple of text boxes and a submit button, but the only thing that I'm really interested in is this right here. This action is, what do I want to run to process this form once it's finished? What code do I want to execute once the user has filled out this form to process the stuff that they typed in? So I told it to use this processform.php file, which is where all the work is taking place. I pull this up. It starts out very similarly with a similar story. Make the connection string. It looks very similar to the connection string that we saw in the last example. Make a connection to the PHP database object. The query is where things start to get a little bit different. Instead of running a query directly, right, I have to pull the values from the form and plug them into the query. So the way that we do that is by preparing our query, and you'll notice that I put in a where clause this time, where first name equals and last name equals, but I haven't actually filled these in. I used question marks as placeholders in my query. And so what that means is before I actually execute the query, I need to grab the values from the form data, which is what this post object is doing. Post first name, post last name, and then substitute those into the query. And so that's what this line of code is doing. You might be wondering, well, why do we break this up into two steps? Why couldn't I just pull those values out and plug them into the query directly? And that's a very good question. There's a very good reason why we don't do things that way, and I'll show you. We'll talk about that towards the end of class today, about why that's not a good idea, why using placeholders and substituting these values in is a better way of going about it. But hopefully the idea is clear, at least, of what's going on in this program. And so, the result statement works the same way. Iterate through the list that you get back. This time I only got one thing, but it's possible I got more if two people had the same name. It's possible I'd get more values. And print out the results. And it works well. If I type in, a value that doesn't exist, like my name, oops, I'm not in the database, so I hit submit and I get nothing back. I get a blank screen. So it's doing, basically what we would expect it to do. Are there any questions about either of the two examples that we've gone through so far? Now let me be perfectly clear on this. This is not a PHP class. I know that some of you have worked with PHP before, which is great. If you haven't worked with PHP before, I want to encourage you right now that you do not need to learn PHP in preparation for the exam next week. That is not necessary. I'm not going to ask you to write PHP code on the exam, but I might ask you to write some SQL on the exam. That is certainly possible. That is definitely possible. I might ask you to write some Java on the exam. That is certainly possible, and we're going to look at Java next, as a matter of fact. So those are things that are possibilities. Writing PHP, though, is not. That's not a possibility. I'm not going to ask you to write PHP code on the exam. I just wanted to show this example as it is a very common way of accessing a database for the purposes of creating a website. Any questions before we look at some Java? I'm going to do the same two things, actually, but with a Java program this time, and show you kind of how they're the same and how they're a little bit different. So let me go ahead and open up the Java version of these. Yeah, what's up?
The files, the process form and the select example that prioritize are, like, it says that they're not found.
Not found? Did I? Oh, okay. Did I not link them properly? Let's see. Not found. Oh, whoops. I know what I did. Hang on. Maybe I can fix this real quick while the thing is loading. Forgot to put the folder in front. My bad. Thanks for letting me know. All right. Let's refresh. There we go. I think they're okay now. Yeah. The reason that I save these as text files and not PHP files, right, is because if I'd saved them as PHP files, the server would try to execute them. You wouldn't actually be able to see the code, and it wouldn't work because there's no database on the web server. The database is on my computer. So I save them as text files. If you want to take these and use them for your own purposes, you should rename them to PHP files and then update the database, the connection string, to match the location of your database, not my database. You should also get the username and password out of here. Typically, we'd store those in a separate file so that they're not as visible. All right, let's see. Yes. Got my Java code up. So let's take a look at how we can do this in Java real quick. That's the tests, which are also interesting, but all right. So let's run through this process. Now, for Java, I had to install a driver to do this. I actually didn't need it for PHP, I don't think, but for Java, I had to install a driver, which is basically, again, a program that tells Java how to communicate with the database server. And in fact, the driver you can see is referenced right here in the connection string, JDBC colon MySQL. That's if you want to run an example, if you want to run this example on your own code, you would need to search for that driver, JDBC MySQL, and install that driver on your machine before you would be able to execute this particular example. You can actually see, here's the driver that I installed right here in the project that I've got, this connector, MySQL connector. It's a free download. You can find it on the internet with a little bit of Googling. All right, so let's take a look. Same general process. We're going to grab a new instance of the driver. Apparently that's deprecated. That's something that has changed since last time I ran this. I'll have to see what the new way of doing this is. And then we get the connection. So step one is always get a connection to the database. And this is my connection string. You can see it looks very similar to the last one. Very similar to the last one. The big difference being that I've got this Java driver being referenced at the beginning. The rest of it, though, looks very similar. I see localhost, I see the port number. That's the database that I'm after, and then the username and the password. It's not exactly the same, but all the same information is there. All the same information is in the connection string. And so I'm going to create a statement, and I'm going to execute a chunk of SQL code. Here it is. That's straight SQL. That is a direct SQL query that I'm executing. Get me the first name and the employee number from employees, and the results get stored in an object called a result set. Now, fortunately, the result set has an iterator with it, or it really is an iterator, might be a better way of thinking about it. So I can call .next, and that will give me the next result. So I just write another little loop. This looks very similar to the loop that I wrote for the PHP example, and I print out result set get string first name, result set get string. So it's like a iterator and a hash map kind of all rolled into one, right? That's how our result set looks, and it'll just print out these contents. Now, one thing that we do have to do, one big difference between what I've got in PHP and what I've got in Java is I have to wrap this in a try-catch because a SQL exception is what's called a checked exception, meaning that we are required to handle it. This exception can occur, for example, if it can't connect to the database. Maybe I'm just not online right now, or maybe the server went down, or something along those lines. So if it can't connect to the database, it would throw a SQL exception. I'm required to handle that exception and say, you know, there was some kind of connection error happening. All right. And then once we're done, we're just gonna close our result set and close our statements so that the connection will close. If I don't actually close the statement and the result set, since those rely on the SQL connection, the connection may actually stay open in the background and continue to use the network, which is not what we want. So it's good practice to go ahead and close the statement, close the result set, which will allow our connection to close then as well. But notice there isn't actually an explicit call to the connection to close it. It just detects that it's no longer being used and then closes itself. And so if I run this, you're going to see similar results to last time. Yo. Did I run the right thing? We're about to find out. Oh, okay. There we go. It's a lot of stuff. You'll notice you could actually see that happening. It took a long time, but the time with this one was not actually the database that was taking the time. It was printing out, taking the time. Java is not known as a particularly speedy language, but it got the job done. Here is that entire table. But again, I'd like to take a look at a more focused example where I can actually tailor my query to a specific result that I'm looking for instead of getting the entire table. So here's another example, very similar. You can see that I fire up a scanner object to ask the user to type in the first name and the last name of the person that they're interested in looking up from the database. And then I run through the same process. create the connection using the connection string, create a statement, and then here you can see I did just use string concatenation here. This is actually an example of what not to do. This is a little dangerous to just use string concatenation here. It'll work, it'll get the job done, but it opens us up to some problems. We saw the same kind of issue happen with PHP, so we'll talk about these problems in just a little bit once we get done taking a look at these code examples. So this will work. It's going to splice the values directly into the SQL query, but there is a problem there that we're going to talk about. And then it iterates through the result set just like we did last time, printing out the values. And so now I can run the program and type in my good friend Pardo Bamford. And it runs the query and gives me back his record. Okay. What questions do you have? Any questions? I got one more code example I want to show you. We've seen it two ways. I got one way to go. Any questions about the Java stuff? Actually, the third example. Oh yeah, question. Sorry.
No, never mind.
Okay, you're good. The third example is actually also Java, but I want to introduce a concept real quick from my slides. So we did PHP, we did Java. This idea of an object relational mapping has become a popular concept, a popular tool when it comes to using databases with your applications. So the idea of an object relational mapping says, all right, I've got objects in my code. Maybe we're using Java code, since that's what we're using a lot in this class, right? Java is all objects. I've got objects in my code, but in my tables, in my database, I don't have objects, right? That's all rows and columns. So the idea of an object relational mapping is, well, let me mark on my Java objects which columns they match up with in the table. So this field from my object matches up with this column in my database. This field matches up with this field. This field matches up with this field. It's called an object relational mapping. I'm mapping the values from my objects to my relational tables, to my relational database. And then what that allows us to do is let the computer handle all of the querying. I no longer have to write the SQL to make it happen. I've marked the mapping on my objects. The computer then can write the queries necessary to retrieve the data from the database and then make Java objects based on that data. A lot of times we'll see a one-to-one correlation. So if I have a Java object called employees, or called employee, I would have a table in my database called employee, right? It'd be a one-to-one. So one row in the employees table would become one Java object that represents that particular employee in my code. And it works both ways, right? I can pull data out, turn it into a Java object. I can then also take a Java object, pass it to the computer, pass it to the system and say, hey, put this in the database. It'll look at that object and say, all right, this value is supposed to go in this column, this value is supposed to go in this column, and just make it happen. It'll write the SQL query for you on your behalf to make those objects persist in your database. It's become a very popular way of dealing with databases. And I want to show you an example of this in action. This is a program. This is IntelliJ, by the way. I'm using this only because this is where this project was developed. I use Eclipse for most things, but this project was IntelliJ for some reason, so we're using IntelliJ. It allows you to make a list of cheeses. I don't know why. That's just what it does. And so I've got a couple of objects over here, Java objects. Let's take a look at one called cheese. And what you'll notice is that this cheese class has annotations. When I see this @ sign, we've seen that before. Where have we seen the @ sign pop up before? Testing for the unit tests. Well, we're seeing it again. Those are called annotations. they're really just markers. They're labels. We're telling Java what this is supposed to be used for. So in the case of a unit test, right, we're saying this isn't just a plain old method. This is actually a unit test. And what the annotations are doing here, this one that I've got highlighted says, all right, this is a class, but it also represents an entity from my database. I want you to make a mapping between this object and the values that are in my database. And so we have to provide a little bit more information, right? I've marked this as an ID column, meaning it's the primary key. This is the primary key. I've also marked it as a generated value, meaning that I just want to use, what would that look like in SQL? Generated value? Auto increment. It's just going to use an auto increment value for this particular instance, for this particular attribute. And then down here, so I've got a string, the name, right? I specified it cannot be null. And I've also specified, all right, the min length is 3 and the max length is 15. So you can kind of see how this would match up to the SQL data types, right? This could be a varchar of 15, for example. And it will live up to that. It will in fact, I should take this a step farther. I can make these Java objects, and not only will it do the mappings for me, but it can create the tables too. If it detects that the table doesn't exist, when I give it an object that I want to put in the database, it'll make the table for me and then put it in there. So it can actually do a lot of work for me. And so all of these are specified. All of these attributes have been annotated so that the system knows, how to map these things together. And then last, but certainly not least, I've indicated that there's a category. Notice category is an object. That there is a many-to-one relationship between this cheese class and the category class. So one category can have many types of cheeses in it, is the idea behind that relationship. So we've marked that this is essentially a foreign key, primary key, foreign key relationship going on between this class and the category class. And actually, if I go over to the category class, I can see, right? I can see the same thing has been done. I've marked this as an entity, and I've labeled all of these values, and here's a one-to-many that specifies, all right, the join column is called category ID. That's the name of the foreign key column, right? And because it's a one-to-many relationship, notice that it's not just a single instance, but it's a list, because there could be multiple cheese objects associated with this category, right? So if I want to retrieve a category object, it's actually going to do the join for me, find all the cheeses that match in this category, create a list, and give it all back. All on my behalf. It's doing all of the SQL work for me. And we can actually see the database that gets created as a result of this. I've got it in my, it's in my PHP my admin. So if I look up, is it this one? Nope. I've got too many. Here we go. It's this one. I've got two tables, category and cheese. So if I open up cheese, you can see ID, description, name, type. There's category ID. That's what we label as the foreign key column, right? It's all here. It's all here. This table was created for us. So it just made a mapping from my objects to the table in my database. And so the last piece then is, all right, how do I actually tell it to put new things in the database or get things out of the database and create objects out of them? That's going to take place in the controller. Some of this has to do with, this is actually a Spring application, a Spring Boot application. That's not a topic that's part of this class. So I'm not going to spend time talking about every single piece of this. I'm just going to focus in on the parts that have to do with the database, like this right here, or like this right here. Cheese DAO.save, and I pass in a cheese object, takes that cheese object, maps the instance variables to the columns in the table, writes an insertion statement to make sure that that value gets put into the table. I'm sure there's a similar one for pulling data out. So categories, what about the cheeses though? Where is the add? Sorry, I'm trying to find the list. Oh, here we go. Cheese DAO.find all. So that's basically select star from the cheese table, right? So this cheese DAO, and there's another one for category. This is actually the link. This is what's doing the work for me. You can see it actually is a very small class. It's not even a class, it's an interface. This is what's creating the link between my Java code and the database. It's called a data access object. So this is what's going to generate the SQL for me when I give it a new cheese object. Or this is what's going to create the new object for me when I say I want to pull values out of the database. And it works. I can show you. I can run this little application and insert a new object and show you that it makes it to the database. It takes a second to start up. So yeah, while we're talking about that, I guess, while we're waiting for this to start up, rather, instead of just standing here, let's talk about whether this is actually a good idea or not. Should you use an object relational mapping? It might sound like I've been, really excited about it and all gung-ho and crazy about using ORMs. I think the advantages are fairly clear, but the disadvantages, there are some downsides. What's a downside of using an ORM? What's the bad part about letting the computer handle all of my database activity? Yeah.
You can't optimize your queries anymore.
Yeah, so the computer is writing all my queries for me. How good are those queries? I have no idea. I have no idea how good those queries are. I hope they're pretty good. In an application like this, it's so small that we're probably not going to notice if the queries are bad. But for a larger application, we certainly would notice if the queries aren't any good. And so it's, I don't get to see that information. Not without doing some digging anyway. You can dig into the output and actually see the queries that are being executed if you really want to. What other disadvantages are there? So another big disadvantage, right, is it can convince people that they don't need to learn how to write SQL at all. The computer's just going to do it all for me. Why do I need to bother? I don't need to learn SQL. I'm just going to use an ORM and that's going to solve my problem. But actually learning SQL is a useful skill. Learning how a database works is a useful skill for reasons such as optimization, for reasons such as normalization. How do I design a good database? It's still important, even if I'm using an ORM, to have a database with a good design, to have a database that's properly normalized, right? That's still a necessary part of setting all this up. Just because the computer is creating the database for me doesn't mean that it's a good database. That part's still on me. And if I don't know what I'm doing, if I don't know anything about how databases work, how SQL works, it's going to be hard for me to design a good database. I'm going to be more likely to, get in a situation where I just have one giant table and I throw all my stuff in it, which is like the worst possible way you can make a database. So that's really the big disadvantage. It obscures the database so much that you can't take advantage of it. You have no way of knowing whether the database is being used effectively or not. It becomes a lot more difficult. Let's see if this finished starting up. It looks like it did. So I'm going to go to localhost 8080/cheese. This is actually a web app you probably just noticed since I typed it into my browser, right? This is Java code that's being run as a web app using Spring. So that's kind of cool too. That's a different class though. If you're interested, come chat with me in office hours sometime. I would love to talk to you about it, but not really what the point of this class is. So these are all from the database. In fact, you can verify that by looking at the contents. Yellow, yummy, it's a cheese. Okay, sure. Cheddar, Swiss, Monterey, right? Cheddar, Swiss, Monterey. And the category, remember, it pulled the category using this foreign key. So if I look at the categories table, I should see the different categories, right? So it used a join to pull that information. And I can add more values to it. Prevel. Oh, yeah. Is it cheese? Maybe. I guess soft is probably the best that we've got, so I'll add this one. And if I go back to my database and I refresh, you can see that it's already been inserted. There's not a line of SQL code in this app. There's no selects, there's no froms, not a single line of SQL code in this application. It's all connected up via the mapping using Java annotations on the objects, which then gets turned into SQL code to perform the operations that we're requesting. And it works. And it works. Does anybody have any questions? Has anybody used an ORM before? Anybody? No? They're pretty handy tools, but I think, again, I think it still requires a pretty good background in databases and how databases work in order to be able to use them effectively, which you all are working on doing because you're here in this class, right? So that's good. I certainly think ORMs have their place, and I certainly would recommend them as long as you know what you're doing, as long as you understand. Yeah?
Those annotations made in Java, or is it part of some separate library?
It's part of Spring, actually. Java does have annotations available just as part of the standard library, yes. Even the ones that we've been using, the app test and the app before, those aren't part of the Java standard. That's part of JUnit, so it's part of the testing library. But actually, you can create annotations just like you create anything else. They're just objects, really, that display a little bit differently. And what an annotation really does is it gives directions to the compiler what to do with that section of code after it's been compiled. Notice annotations don't get executed, right? It's more like you're dropping hints into your code to indicate what you want things to be used for, so that the computer knows how to hook everything up behind the scenes. They're great because they keep things simple, at least code-wise. It keeps things very simple. But they're also kind of dangerous because, it's for the same reason. It obscures some of the stuff that's happening, right? It pushes some of the work off the screen so that you don't actually see what's going on. And so when something doesn't work, it can be harder to figure out why, because you're not seeing the whole picture. So that's sort of the pros and cons of using annotations in your code. But the longer you stick with it, especially with Java, it's pretty inevitable. You're going to run into annotations sooner or later. Hard to avoid them. Great question. Any other questions? So the last topic I want to talk about today. Oops, wrong one. I mentioned this a couple times with the first two apps that I looked at with PHP and the simple Java application. And the Java one in particular, I wasn't really happy with how I constructed that query. There was a problem with it. Does anybody know what the problem is with that query that I had? I can pull it up, actually. I think I probably still have it. This query here, where I just used concatenation. What's the problem? Yeah?
I didn't check for the user input.
I didn't check the user input at all. So I just had two text boxes. The user could type whatever they want into those text boxes. Whatever they want. And I've just taken that value and inserted it directly into a piece of code that's going to get executed on my database. So if they know what they're doing, they could really cause some damage. This is called SQL injection. Probably have heard about this. So I can write some SQL code into those boxes and maybe cause some problems. Maybe cause some things to, not work the way that I intend them to work. Or worse, expose data that I don't want to be exposed. Or worse, destroy data in my database. Just cause some destruction. It's a very dangerous thing to leave exposed. So the proper way to deal with this, is to keep your user input separate from your SQL code as much as you possibly can. The PHP did a good example of that. If I have the PHP example, which is here, you can see that I used placeholders and then inserted these values after the fact. Actually, what I would want to do is probably take that a step farther and do what's called escaping. Basically, what escaping means is it's looking for certain types of punctuation that's commonly used in code, and then basically nullifying it in a sense. So you could look for parentheses or semicolons or things like that, equal signs, things that you wouldn't expect to show up in somebody's name anyway, right? I don't know anybody that's got a parenthesis in their name. So you could look for things like that in the user input and then escape them out, basically is nullifying their effect as code, treating them more like text, just plain text instead of like code. Which gets to the overall point of validation, validating user input. So let's talk about SQL injection a little bit. You know, this is unavoidable. I need to get information from my users to write effective applications. That's unavoidable. An app that doesn't get input from your user is not going to be as useful in a lot of cases. So we just need to watch out for stuff like this. Here's a classic example of SQL injection. This is actually also a really bad example of how to check for a password for other reasons. You know, the first query that you see here in the middle is how maybe they're checking for the password, perhaps, right? The second query is how somebody might try to alter how to use SQL injection. So what did they type into the password box? They typed this in. They typed in that. And so that has the effect then, X is always going to equal X. So that's true. So now it doesn't matter what the password is, because you've said that this statement's going to be true, which means that you can now effectively bypass the user's password and log in as that person. This is a pretty extreme case, right? SQL injection is well known enough that I would be very surprised if you found a website that let you get away with this kind of injection these days. It'd be very, very difficult to find a site that lets you get away with this. But this is a classic example. And back in the early days of the internet, you could get away with this stuff all day long. It was like the Wild West out there. So, you know, other things that you can do, perhaps more malicious things. Maybe you detect that there's a line of code that looks like this. And what translate does is it takes in a value, and then anytime it finds this string, it just replaces it with this string. It's a replacement. It's SQL's version of string replace. And so what you're saying now is, well, let's replace that with a call to make an HTTP request to a website that's going to pull down maybe some malicious code that is now going to be on your database server, and now I can run that code on your server. So I have now inserted a request to an external website into this application. That's called code injection. Another very common path to attack somebody's app that's based on a database. And these are just a couple of things to be aware of. Other risks from SQL injection. So database fingerprinting is the act of using SQL injection to determine the structure of the database. What tables exist? What columns are in those tables? What are the relationships between those tables, right? Using injection to determine the schema. Usually it's like casing a house before making a robbery, right? I'm going to check out the layout of everything, try to find where the good stuff is, and then once I found it, I can make a more focused attack on that particular area. I can do denial of service attacks just by making requests that make the server take a long time to execute, therefore, denying service to people making legitimate requests. I can bypass authentication. We saw that with the password. Identifying injectable parameters has more to do, again, with sort of casing the website a little bit, trying to figure out, okay, maybe I can't get into the password parameter, but is there maybe the username is more susceptible. Maybe I can try a couple of different queries with some of the different inputs to figure out which ones are weaker than others in this particular system. Executing remote commands is what we saw with the code injection, right? If I can execute commands remotely, then I can execute whatever I want. And that really is the ultimate goal of any hacker, is how can I execute any piece of arbitrary code on your computer? Because then I have full control over it at that point. It's my computer now, basically, right? And then performing privilege escalation would be like convincing the computer that you should have admin rights. So maybe I actually have a legitimate user account that just has plain old user privileges, user access, but I can use SQL injection to convince the server that, oh, no, wait, actually, I'm an admin. You should give me admin rights. And now I can just go in and do whatever I want on the system. These are all common things that can happen with SQL injection. And again, the solution to this problem is sanitizing your inputs, validating your inputs. I use that term escaping. It literally means going in and inserting escape characters in front of things like parentheses, in front of things like equals signs, so that when you see them in the code, it won't function properly. It won't work. It'll still work as text, but it won't work as code. And it's probably a little bit cliche by now, but everybody's seen the Bobby Tables comic, probably. Can I pull it up? Did you really name your son Robert, drop table students? Oh yes, little Bobby Tables. We've lost all this year's student records. A very famous example of SQL injection. This comic is old, actually. How old is this comic? When did it actually come out? Bobby Tables. It's so famous that there's a whole website called Bobby Tables. Wow. That's awesome. I did not know this. Sorry, this just made my day. Yeah, okay. And so they give examples of how to prevent SQL injection. That's fantastic. I love it. That's fantastic. So how would you do it in Java? This is a great question, because the code that I gave you was not good, right? The code that I gave you did not protect against SQL injection. So how would you properly do it? We have a class called prepared statement. And so it looks like we create prepared statement, and we use question marks as placeholders again, and then we use set string and set int. Yep. So what these set string and set int things do is they look at the content that you're passing in, especially for strings. Strings are the big problem, but anything can be a potential issue. It's going to look at this string that you've passed in. It knows that it's going into a SQL query, so it's going to check that string for you as part of the set string operation and take out any weird stuff that it finds in there. It's going to do the work for you on its behalf. SQL injection has become so widely known that every language that interacts with databases has quick and easy ways of dealing with it these days. But if you just do the concatenation route like I did, you're opening yourself up to potential problems. Cool. That's awesome. I didn't realize that was a thing. I'm really glad that it exists. I'm going to read that later, though. What I wanted to do right now... Well, first off, are there any questions? Any questions? Cool. All right. Okay. Yeah, here's an example of what I was just talking about. For the last 15, 20 minutes, you guys are going to become hackers, and you're going to use SQL injection to crack into a database. This is a database that was set up online specifically for teaching people about SQL injection. So you are welcome to use SQL injection on this database without any repercussions. Don't do it on another website. People will get mad at you. They'll get very angry. And you might even get into legal trouble if you try to do this on a website that is not been pre-approved. And so you can see it's just a very simple name and password situation. They ask you right off the bat to try something simple, right? Enter the string or equals as both username and password. So I don't even know what the username and password to log in for this thing is, but if I type in the right SQL command, it just, boom. Typed in a chunk of SQL that gets substituted into the SQL query that's verifying usernames and passwords, and it logged me in right away. The exercise that I wanted to take at is this one that's called find a password. So if you scroll down a little bit, you should see this exploit called find a password. Uh-oh, I don't know. Do you guys see there should be the login thing here, but I don't see it. Do you guys see it? No? Is it broken? Well, that's a little inconvenient. However, what you can do is you can actually just use this one, I guess, on the front page. This one should still work. I wonder why that happened. But anyway, there is a user who's called Jake. The username is Jake. I want to know what his password is, and they give you some clues. So I can use this to find out if Jake's password has a W in it. So let's take a look at this one real quick and see if we can understand what's going on, right? Or exists. Select star from users where his name equals Jake and password like. So like is actually SQL's way of introducing what's called a regular expression. You guys familiar with regular expressions at all? So a regular expression is how we do string pattern matching. I give it a pattern and it tries to match that pattern. And the percent signs mean that it can be any character. It would be equivalent to what's usually a star in most regular expressions. For SQL, it's a percent sign. So I'm basically saying I have any number of characters followed by a W followed by any more letters, which means if I find something in the password table that has a W in it, that pattern is going to match, which means a password does exist that matches this pattern, right? And so I'll know that Jake's password has a W in it if this lets me log in. If it doesn't let me log in, I know that Jake's password does not have a W in it. There is no W. Notice that this particular query does not tell me anything about where the W shows up. Is it the first letter? Is it the last letter? Is it somewhere in the middle? Could be all three, as far as I know. It does not narrow down where the letter shows up. So there's some other queries here that can help you figure out things like that. And you'll notice that the main difference is just that they're using slightly different regular expressions to see what patterns match his password. So you don't have to use these that are listed here, although they'll certainly be helpful. What I want you to do is figure out what Jake's password is. We got 15 minutes left in class. I'm going to give you 5 or 10. Talk to your neighbors, put your hacker hats on, and see if you can figure out what Jake's password is using the resources here. And again, remember, I don't know why it didn't show up here, but
is it higher, like on that same page? I don't know, like I don't know. Like no, wait, look at the box below the work, or that's the workspace.
Yeah, no, it just isn't showing up for whatever reason. I guess I can go into the source and see he's using an iframe, and there it is. He's this is an iframe, which means he's basically pointing to another page, and for whatever reason that page is not loading. So you got two options. If you are feeling adventurous enough to dig into the source code and find the iframe, you can load it up that way, or you can just go back to this page and use this login box here. It should work. But either way, take a few minutes, talk to your neighbors. You know, one of you could have this page up and the other one could have the login page up, and see if you can use queries similar to this to figure out what Jake's password is. We'll talk about the answer in a little bit. I'll be around if you have any questions.
So you can change W to A.
So these are like this middle one's called you have to modify this to help you figure out what other letters are in there. So it doesn't let you log in. Yeah, it doesn't let you log in, and you guess the wrong letter or the wrong position.
Well, I discovered that they have 3 letters. I'll have to try out vowels Well, I do. Like it could, you're the best to figure it out. Okay, so how do you measure?
This is a very simple
Okay.
so I mean, I could write a program.
Yeah.
Not that I know of, but I mean, you can get very good with regular expression on a lot of things. So it's not you don't have to brute force it as much as like testing every single letter. There are faster ways, although testing every letter also works. So you use character range on that almost lets you do like wide.
So let's have a
Yeah, for now you're doing the best you can with it.
It's got to be at least 400. It's constant.
Alright, we're running out of time. I'm actually not as interested in what the actual password is, but more the techniques you use to figure it out. So what did you guys try to do to figure this out? Anybody want to explain the process? Yeah.
Oh, I started with vowels to try to see if I can determine if there's
Start
a
with
common
vowels. So
word.
just changing the query, right, to just replacing the letter, trying different letters to get an idea of what letters are in the actual password. Okay. Anybody try anything different? Yeah.
We started with trying different numbers and underscores to find the length.
Good, yeah. So the bottom one here shows you how underscores, that's going to match a single character. So if I just put in only underscores, eventually it should tell me how long the password is. How long did you figure out that it was? 6 characters. Okay, cool. So using a combination of those two things, I can figure out that it's 6 characters long, and I can also figure out which letters are in the password. Did anybody figure out which letters are in the password? Did anybody try all 26? There's definitely a W, right?
Yes.
What else we got? L, D, E, O. That's only 5 letters. So that means that one of them shows up twice, right? One of them shows up twice. That would be a tricky one to figure out how to write a query for, perhaps. It's not that bad, actually. You could probably just do the top query and then put another O % sign on the end, and that will tell you if there's 2 O's in the password. Right? And so then, once you know the length and you know what letters are in there, the last thing to do is to figure out the order. You can speed this up if you assume that it's probably an English word, which I actually don't remember what the password is. Is it an English word? It's Elwood, which is a name.
That's 2. That's 2. Oh.
2 O's, yeah, that's right.
Okay, I thought you said 2 L's a second ago.
6
Sorry.
characters. It's an English name, not necessarily an English word, but you know, if you assume that they use something, you know, English as their password, could help you narrow down those options. If not, then what do you got to do? You got to do something like the second option up there. Try each letter as the first character until you find it. Then try the first 2 letters, right, until you find it, and then the next 3 letters. Somebody asked me, is it always going to be this tedious to brute force the password? Am I going to have to try it out? And the real answer is that in practice, the hackers aren't sitting there modifying these SQL queries. They wrote a program. They got a program that's going to make these password requests and figure out which ones work and which ones don't, to quickly figure out what the password is. It's not going to be somebody sitting there trying it out over and over again. But in practice, I doubt there are many people trying stuff like this anymore because it's just not going to be effective. For starters, SQL injection is much more difficult to do today than it was a long time ago. And now sites do things like prevent you from having a certain number of incorrect logins. They'll just lock your account. You failed to log in 5 times, you're locked out. I can't help you anymore until you give us a call on the phone and let us know what's going on, right? Or reset your password. So there's a lot of other security mechanisms in place that make this kind of process difficult these days. But in theory, if you find a website that doesn't use good security practices, you could hack in this way. And lots of other ways too. There's other options on this website for how to use SQL injection to figure out different things about this database. So if you had fun with that little exercise, you can go home and pretend you're a hacker tonight. If you get into trouble, though, it's not my fault. That's on you. So I guess that's it. We're out of time. I will not see you Thursday, but I hope you have a good rest of the week. I'll see you back 1 week from today for the exam review.
What about Tuesday? We'll see you on Tuesday also. Oh yeah.
1 week from today. Yep.
Is it okay if I